Hi everyone, this video is on exercise 9F questions 6 and 7. So if you have watched my previous videos, which are the ones that were on trigonometric differentiation, I kept repeating that we can either use the standard results in order to differentiate trigonometric functions or use the more direct differentiation, and I mentioned that I'm going to show that in the future videos. And in this video I want to show us how can we use some of those more direct methods rather than stating a standard results, because based on the standard results we know that, for example, sec x differentiates to sec x tan x. But what if we forget this in the exam? What can we do? Is there a direct way of just differentiating? And the answer is yes. So in this case, the first thing before I should differentiate this, sec x is equal to 1 over cos x. So that's the first step. Always write down the functions in the forms of that include sine and cos, because you already know the derivatives of sine and cos, so that way it's way easier. And now the objective is to differentiate 1 over cos x. So the good news is this is the quotient rule, because the denominator is going to be cos squared x, and then we write down the denominator function times the derivative of the numerator, which is 0, minus, this time we write down the numerator function, which is 1, times the derivative of the denominator function. So cos x differentiates to minus sine x. And this simplifies to sine x divided by cos squared x. So this is a derivative, but the question is asking us to show that this is equal to sec x tan x. So this means we need to continue and use trigonometric identities in order to get to that form. But this is the derivative. You can leave your answer in this form, but it's not the nicest form. So we can't do anything with the numerator, so it's just sine x. But for denominator, let's rewrite cos squared x as cos x times cos x. And here the interesting thing here is that we have cos x, sine x over cos x, and we already know that sine x over cos x is tan x. So if we split the fraction into two fractions, sine x over cos x times 1 over cos x, which are equal. So sine x over cos x is just tan x, and 1 over cos x is sec x. And this is exactly what the question is asking. So yeah, this is the direct way of differentiating. And if you use the direct method, I mean, you can just leave your answer in this form if you are not asked to do so. So that's completely fine. But again, it just depends on the question. So you need to look at the question and see what the question is really asking. Okay, question 7. We have y is equal to cot x, and we want to differentiate that and show this is equal to minus cosec squared x. Again, we use the same approach, because cot can be written as cos x divided by sine x, and in our differentiation we are going to use that form, which includes cos and sine. So again, it's another quotient rule. So the denominator is sine squared x, because we square the denominator. For the numerator, we write down the denominator function times the derivative of the numerator. So cos x differentiates to minus sine x. So that's the first half. And for the second half, we start with the numerator function, which is cos x, and differentiate the denominator function. Sine x differentiates to cos x. So let's simplify this. Sine x times minus sine x is minus sine squared x. And here cos x times cos x is cos squared x, and it's minus, so minus cos squared x over sine squared x. So this is the derivative, but obviously it's not in the form that we need to show the answer. So let's simplify this. First of all, we can factorize and take a factor of -1 in the numerator. So minus sine squared x plus cos squared x divided by sine squared x. So this is a trigonometric identity because sine squared x plus cos squared x is 1. So it's just going to be -1 on top. So it's -1. And denominator is sine squared x. And we know that 1 over sine x is cosec x. So in this case, we have -1 over sine squared x. So it's just going to be minus cosec squared x. And that's it. So we have shown what we were asked for. Okay, that's it for this video. Thank you for watching.